And to do this part of the question, we are going to make use of differentiation. First, let's try to differentiate a with respect to theta, which will give us a dA d theta. This is going to be equal to 60 cosine theta plus 36. Of differentiating this, we have a 2 cosine 2 theta. So dA d theta is equal to 60 cosine theta plus 72 cosine 2 theta. Next, in order for us to find the maximum possible value for A, we will try to work out the value of theta that cause A to be stationary, and that is when dA d theta is equal to 0, which means that we are working on a 60 cosine theta plus 72 cosine 2 theta to be equal to 0. So this will be 5 cosine theta plus 6 cosine 2 theta is equal to 0. Let's try to re-express this entire equation in terms of theta instead of 2 theta. So 5 cosine theta plus 6. Re-expressing this in terms of cosine theta, it will be 2 cosine square theta minus 1. This is equal to 0. So we have a quadratic equation in terms of cosine theta, that is 12 cosine square theta plus 5 cosine theta minus 6. And to solve for theta, let's first try to find cosine theta by making use of the quadratic formula. So it will be minus b plus or minus square root of b squared minus 4ac. This divided by 2a. We're going to be getting two values. The two values will be minus 5 plus or minus square root of 313 divided by 24. And looking at the theta that we are working on, we know theta is going to be an acute angle. So cosine of an acute angle should be a positive number. So we are going to reject one of them and keeping just minus 5 plus square root of 313 divided by 24. Because with the negative 5 minus square root of 313 is going to be a negative number, which is not what I want. So, and this is because the theta that I'm working on is an acute angle. So it is between 0 to pi over 2. Which means that theta is just simply going to be cosine inverse of this, minus 5 plus square root of 313 divided by 24. Pressing this into the calculator, I'm going to be getting a 1.0136. We need to try to show that this, which is a value that causes A to be stationary, is also going to be a value that causes A to be a maximum. So let's make use of the second derivative test. I'll take this and we'll differentiate it one more time. So d square a d theta square. Differentiating this again, we have a 60 of minus sine theta plus 72 of minus 2 sine 2 theta. So when theta is equal to 1.0136, we can find the value of d square a d theta square by substituting all the theta by 1.0136. And when you do that, this value is going to be equal to minus 180.19. This is less than 0. This tells us that A is at its maximum, which means that the value of theta that causes A to be maximum is going to be this value. So theta is, to three significant figures, 1.01.